In this example, the mean of a sample of 25 observations is 6.4. The mean of a second sample of 30 observations is 7 point. Calculate the mean of all 55 observations. So first, we would have x equal, so the summation of lowercase x divided by n, where x would be summation, the lowercase x will be the summation of data, and the x capital represents the mean, and the n represents the number of data values. So in this scenario will be represented in the form of 6.4 equal will be the summation of x divided by n. In this scenario we have 25 observations, so to solve this we would have the summation of x will equal the 6.4 multiplied by 25, which will give us 160 for the first observation. For second observation, again we use the same formula, but in this scenario we are using a different value, so it will be y summation of y of m. So again, y represents the mean, and the summation of y represents the data values, the sum of data values, and the m will represent the number of data values. So in this scenario, y will be represented by 7.2, which is the sample mean of the second sample, which will equal summation of y over m, which is represented by 30. So in this scenario we would have summation of y will equal 7.2 multiplied by 30, which will give 216. So in this scenario, to find the mean, we would have will equal, we will take the summations of x and the summation of y, so that will give us in this scenario 260, all divided by the samples of the mean of x and y, so that would be 25 and also 30. So that's the number of first and second samples of observation, so the total m. So in this scenario that will give us 8, which will be the value of the 55 observations, which is the combination of, and this will be our answer for this. In this example, Rebecca records the shirt collar size X of the male students in her year. The results are shown in the table. Find for this data first the mode, B the median, and C the mean. So first let's start with the mode. So in this scenario, based on the information on the right hand side, the mode will be in the scenario 16.5, and for the median, that will be which is the highest color size in the scenario, so we say highest. Now we look at there are for part B we need to find the median, so there are 95 in the scenario observation, and so median, therefore median will equal 95 plus 1, and that will be divided all over 2, and that will be equal to 48, which will be the median for this part. And now based on the data given, and there are 20 observations up to 15.5 and 49 observations up to 60. So in this scenario, the median will be 6, will equal 16. Now for part C, we need to find the mean. So for us to find, we need, which is represented in the form of x, that means we take the summation of the answers and each one of them multiplied. So we'll take the color size multiplied by the number of students for each one. So that will be for the first one 15 multiplied by 15.5 multiplied by 7 plus 16 multiplied by 29 16.5 multiplied by 30 plus we have 17 multiplied and divided by the total. In this scenario we have the addition of all the students, so that would be 9. So that should give us approximately, when we simplify this, it will give us approximately 16, and this will be our answer for. Now for part D, we need to explain why a shirt manufacturer might use the mode when planning production numbers. So our answer for this explanation will be actual data gives manufacturer information the most common size worn or slash, and this will be our explanation in terms of why a shirt manufacturer might use the mode. So mode is an actual data value and gives the manufacturer information on the most common size worn or used, and this will be our answer for this. In this example, Meryl collected wild mushrooms every day for a week. When she got home, each day she weighed them to the nearest 100 gram. The weights are shown below, so 500, 700, 400, 300, 900, 700, and 700. So there is 7 samples or 7 weights. For part A, write down the mode for this data. So the mode, we can see the highest, which is 700. So we say equal 700, so in this case is gram. So we say highest. Now, and it is the most often occurring. So this will be, as per the mode, is the most often occurring, and this is our answer for part B. We need to calculate the mean for this. So in this scenario, we add all the values. So we say all equal 500 plus 700 plus 400 plus 300 plus 900 plus 700 plus 700, and all divided by 7, as we have 7 values, so that should give us 600 grams, which will be the mean value. For part C, we're asked to find the median for this data. So we can see that median is equal, based on the information we have, we can see that 700 is more repeated, so we can say that it is 700, which is the median of the data. So we can rearrange this information in terms of 300, 400, and we have 500, and we have 700, and we also have another 700 and another 700 and 900. So in this scenario, the median will be 700, middle value. So we say middle value. Now for part D, write down the effect this will have on the mean, mode, and the median. So we say that it will increase the mean, as it's 650 is bigger than 600, the old mean. The mode will be unchanged, so that's the mode, and this is the mean. Also, it will increase the median. There will now be an even number of values so we take the middle pair, 650 and 700. So this is the pair that we take from the middle, and the new median will be halfway between these, so approximately 675. So this will be our answer. So for the first part, for the mean is the 650 will be bigger than 600, so the old mean. The mode will be unchanged, and it will for the median it will increase. There will be now an even number of values, so we take the middle pair, which is the 650 and the 700, and the new median will be halfway between these two values, which is the 650 and 700, so we take approximately 675, and this will be our answer for this question. In this example, we have a question that where Joe collects 6 pieces of data, x1, 2, 3, 4, 5, and 6. He works out that the sigma of x's is 256.2. So first we need to calculate the mean of data. So we will start with finding the mean. So that will be, we're told that to find the mean, it will be sigma x over n. So in this scenario, it will be 6.2 divided by 6. We have 6 data values, and that will give us 42.7. That will be our answer for part A. And for part B, we are told that we need to write down the effect this piece of data it will have on the mean, which is we're told that he collects another piece of data, and it says 52. So we say it will increase the mean as the new piece of data, which is the 52, is greater than the old mean, which was 42.7, which we found in part A. And this will be our answer for this.